Let's discuss the code for implementation of AVL tree. We all know that AVL tree is a type of binary search tree, but the only constraint in AVL tree is that it must be height balanced tree. So height balanced tree, it means balance factor of each node is either 1, -1 or 0. And we know how balance factor is calculated. It is height of left subtree minus height of right subtree. So let's see what will be a node structure in order to implement AVL tree. So let's see the outline of program. So first of all, we will include all the header files which are required, and second is about node structure. So here in this program, we will be inserting integer values in AVL tree. So the structure of node will be like data will be of integer type, and this is also the type of binary search tree. It means this will have left pointer and right pointer. So here the first parameter is int data, second field is AVL node star left, and third is AVL node star right. So a node will have these three fields. Then next is about class outline. So here we have defined one class AVL tree, and in this class we have declared different member functions which are required for AVL implementation. So the first important function here is insert. So we can see the prototype of insert function here. It takes AVL node star as a parameter with the value which is to be inserted in AVL tree, and it returns a pointer of AVL node star type. Okay. Second function is display, which will be used for displaying the contents of AVL tree. And in order to balance the AVL tree, we need four types of rotation: RR, LL, LR and RL. So these are the prototypes for these four functions. They are also taking AVL node star as a parameter, and they are also returning AVL node star as a return value. Now internally, when we insert any node in AVL tree, it will calculate balance factor of each of the node. So to calculate balance factor, the function defined here is balance, and this balance function will be invoked after every insertion. Internally, the balance function gives call to the difference function DIFF. So this function basically returns the difference between the height of left subtree minus height of right subtree, and difference will internally give call to the height. So the hierarchy of functions invoked will be like balance, which will internally call DIFF, which will internally call height function. Okay, so these three functions are interrelated, which will be invoked every time we insert a node in a AVL tree. So this would be like when we insert any node, balance function will be called on the parent node of the newly inserted node. So if you have only one node, there is no need of invoking balance. When we insert second node in a tree, so we will call this balance function on the parent node of second. Okay, so this is how, unless we reach to the root, this balance function will be recursively called for parent's parent and parent's parent and parent's parent unless we reach to the root level. Okay, so this is outline of AVL tree class, where we have declared some functions, required functions, that is types of rotation, insertion and display function. Then this is constructor, which initializes this value of root to null, just like we used to declare head is equal to null. Okay, now let's come to the main function. In main, of course, it will be a menu driven program where you will have first choice for inserting a number in a tree, and second choice for displaying a AVL tree, an AVL tree, and third choice is exit here, where you will exit from the program. Okay, so when we call this insertion function, we pass the root, which is initially null, and second parameter passed here is item. So item is basically a key that we want to insert in a AVL tree. We will see in detail how this insert function is called. And second is display function. So if root is null, nothing to display as such. Otherwise, it will call display function by taking first parameter as root and one is a level. Okay, level wise will be displaying tree starting from the root going towards the leaf node. And third case is exit. If we enter choice as 3, will exit from the menu driven program. And if apart from this 1 2 3 user enters some other choice, it will just display wrong choice. Okay, so this is what outline of the program, where we have seen inclusion of necessary header files, followed by structure of node, followed by outline for the class, followed by main. Okay, now let's see different functions which are very crucial for implementation of AVL tree. Now let's start with insert function. Now in order to insert a node in a tree, we will ask the user to enter the value first of all that we want to insert in a tree. Okay, so this is the insert function. Okay,